Let's take a look at a couple of examples, and we're going to start with number 1. Okay, so a line passes through these 2 points, P and Q, and a second line passes through these 2 points. Are these lines parallel, perpendicular, or neither? Well, when we draw it out, we're going to be able to figure out if are they parallel or perpendicular, or might they be parallel or perpendicular? Because if they cross, they could be perpendicular. If they don't cross, they could be parallel. But it'll be the slopes that we're going to find that are going to definitely show that in fact they are or are not perpendicular. So let's draw these out first. 2, 4, 6, 2, 4, 6, negative 2, negative 4, negative 6, negative 2, negative 4, negative 6. All right, so let's draw out the lines. So the first one here, P and Q. Now when we're drawing out lines, what we're going to do is we're going to label them, okay, using using the points, okay, or we can label it using the numbers. So negative 7, 2, negative 7, positive 2 is right there. This is P, and that's all we need to do, just P. We don't have to put the coordinates in because we know what the coordinates are. And Q is at 1, positive 7 right there. There's Q. And then when we draw a line through, we're going to find those 2 points, and we're going to draw a line through, put some arrows at the ends, and figure out, and that's our line. Okay, so that's line segment PQ. That's it drawn out. And again, we could put the coordinates in there as well, but in this case, we don't have to because we already have the coordinates here. The second line passes through R, which is negative 3, negative 3, negative 4, which is right there. So that is R. And S, which is at positive 5, positive 1, which is right there, S. And again, we're going to draw a line through there. And we can now determine, are they going to be parallel, perpendicular, or neither? Well, first off, which one can they not be? Perpendicular. I hope you all had a rousing expression on that one there. They're not going to be perpendicular as they don't cross. They're looking pretty close to parallel, or they might be 100% parallel. And so we're going to have to see, are they in fact going to be parallel or perpendicular? Well, you could do a couple different ways. I'm going to actually use the formula to solve it. Okay, so instead of finding it on here, I'm going to use a formula. If you would want to use the graph, you gladly can. But our formula states that m is y2 minus y1 over x2 minus x1. And we're going to start with line segment PQ. Now I'm going to use P first and then Q. So P, so our slope is 2 minus 7 over, sorry, I did that backwards. P is my first point, so it's the second one that I put in there. So even I sometimes make this mistake. 7 and 2, because this will be y2, this is y1, this is x1, and this is x2. And then we're going to have 1 minus negative 7. This is going to give us 7 minus 2 is 5. 1 minus negative 7 is 8. So this one has a slope of 5 over 8. We could also do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. And that's what we graphed out as well. Okay, so this one has a slope of 5 over 8. Now, if they are in fact parallel, that means that this one will also have a slope of 5 over 8. And so let's look at line segment RS. So I'm going to again use R first, then S. So this is x1, x2, and y1, and this is x2 and y2. There we go. So we're going to do 1 minus negative 4, and we're going to do 5 minus negative 3. 1 minus negative 4 is 5. 5 minus negative 3 is 8. These are identical. So we can say, therefore, the two lines are parallel as they have identical slopes. Okay, identical slopes means that they are parallel lines.